All right. Um, so now I want to go over this constant acceleration worksheet with you guys. We'll talk about some of these in class, or we already have, but I want to kind of take a little bit more time for some of you who need that to be able to sit and watch and kind of go back and pause and look at your work and stuff like that. So the first one that we struggled with here was the first graph. So this velocity versus time graph here that shows motion with a constant acceleration for the first 20 seconds. So, part of this is deciphering what this is saying. So what we've talked about in class, or will, is it does help you guys to think about what's going on in terms of the problem. And so when I think about the time and the velocity here, it starts at rest. And so whenever you read or hear something starts at rest, that means that at time zero, its velocity is zero. So I'm just going to add those to my chart. And then it ends up moving at 30 meters per second during a time of 20 seconds, and it had accelerated to that. So that means at time zero, it was going zero, and then it sped up in 20 seconds, so a time of 20, to ended up being at 30 meters per second. And I should add some units to these. Whoops, a 9, what's going on there? And time is in seconds. So, and then what it says is it continues at 30 meters per second for 10 seconds. So 10 more seconds, so a total of 30 seconds, and it's still going 30. So what's happening here, it's speeding up and then staying at that speed. So you got to kind of get that mental picture there. So if you were able to come up with those points, then I think that makes graphing it pretty straightforward. And so I'm going to go walk you through that graph. I've put those into a Google Sheet already. Right here, you can see I've typed in time and velocity. And if you are still making graphs based on the first video that I had uploaded from YouTube that wasn't me, you want to scrap that, because someone had pointed out that that was before they updated Google Sheets. So watch what I do, because it's really easy. So I got to label my columns here. So make sure you do that. And I've got those points right there. So then what you're going to do is highlight those and you insert chart. And you do that, and it comes up with your chart right there for you. Let me zoom out of this a little bit. So it has my chart right there. It's all good. The only thing that looks weird because it cuts off here. So if you've seen me do this already, I'm going to customize this. And I want to look at my vertical axis. So I click over here and I scroll down, and it has my vertical axis. The max says 30. I'm going to make that 35. It actually makes it 40, but it's all good. So now I've got a beauty of a graph right here, and I click on the snowman. I want to copy that chart, and I go back to my worksheet, and then I right click and I hit paste. It asks me, do I want to link it to spreadsheet? And I do. And then I put my chart in there, my graph. I'm going to just make it a little smaller. Boom. And that's what our graph should look like. So we've got velocity and time on the x-axis, and that's what that looks like. So then question 2 says, what's the rate of velocity change for the first 20 seconds from this graph, and what does it tell us about the motion? So the rate of velocity change, that's how much velocity changes over a certain amount of time. So the velocity went from 0 to 30 in 20 seconds. So the rate of velocity change went from 0 to 30, so it changed by 30 meters per second, and it did that in 20 seconds. So 30 divided by 20 is 1.5. The unit for that is meter per second So that's the numeric answer, and this tells us the acceleration of the object. And one thing that you've got to get going in your brain is that is also the slope. And we've talked several times, the slope of this line of a velocity time graph is acceleration. So that's really the easiest way to answer that, is just looking like that. Um, so I'm going to bold my answers for you. And then here, explain the difference between velocity and acceleration. If it helps, use examples from driving in a car to better explain. So typical answers for this were kids gave me definitions, which makes me think you must have looked at it up online. And so, you know, that's fine if you define them. And if I were defining these, I would say velocity is, speed and direction. Okay, so that's that. Remember, velocity is the vector of speed. So how fast you're going in a certain direction, or how much distance you're covering in a certain amount of time. Acceleration is the change in velocity over time. So those are good definition-wise. I'm not convinced that when you give a definition that you actually understand what that means, which is why I thought maybe you would say something about a car. So in a car, the velocity is how fast you are going and which direction. So you might be going like 55 miles per hour west. To accelerate or change velocity, we talked about 3 things you could do in class. You can speed up, slow down, or turn, change direction. So let me just fix that. And I mean to accelerate in the car, to keep it on that. So, you know, you could use an example of like, maybe you're going 55 miles per hour, but then you approach a traffic jam, so you have to slow down, and that it would be your negative acceleration. So anything like that would work out good. So those were kind of, that was kind of a little more conceptual, and then we got to the math part here. And so the math part, as we talk about in class, you know, units are important. I think it's really important for you to show the equation. And that's what we went over in class on September 21st. So we have a whole bank of equations. I've added these two to it, which are just the same as this. I just reworked them algebraically. And it might have been, if you're in 4th, 5th, or 6th hour, I think this was on 922. But so keep that in mind. So from what we talked about in class, you got to have access to these. So I've talked to a few kids who they were like, oh, I just had forgot what they were. Well, you got to get these notes written in someplace handy, whether it's a notebook you're using or whatever it is, so that you can use them when we solve problems. So most of the acceleration ones here, we did fine with. The ones about how far, we struggled with. So when I'm asking for acceleration, so in that case here, I go from 30 to 145 in 11.6 seconds. So I just want to use this equation here. And so you will plug those numbers in. I'm gonna pause it and come back to that in a minute. So reading these, here we have a question of how fast. So when it says how fast, I know that this is asking me for a velocity. So I've got to have some equation for velocity there. And so that would help me figure out what that is. Acceleration, I'm solving for A. When it says how far, so these are ones where it's asking for distance, what distance equals. So you've got to think about which equation you're going to use. Here's another acceleration. Here's another how far, acceleration. So I'm going to pause this. I'm going to insert the equations I would use, and then I'll get going again. Okay, so I've gone through and put equations and numbers in there, so you can look at things that you did and kind of maybe fix mistakes there. So with this first one, change in velocity over time, I think almost everybody got that one, so that was good. This next one, where she's driving this car, So what some kids did is they forgot to add the initial velocity here. So that part, just adding the 15. But this equation right here is the one you would use there. And we're going to see a couple instances where we use that over the next few problems here. Some people, I think, just did this in their head and just did it backwards. They did 300 divided by 2 instead of by 0.5. So what you had to do with 6 and 7 is you found the acceleration, and then you had to use it in this distance formula. So this distance formula, you've got to get pretty comfortable with because we're going to use it a lot. And so this is when something is accelerating. So that distance formula is for when something is accelerating. If it's not accelerating, if we have a constant velocity, then we would do average speed times time, or average velocity times time, to figure out the distance. But if it's accelerating, use this equation right here. And so then it took my 600 here, and I had to plug that in down here for this equation. So it's 1/2 of acceleration times time squared to get that answer. And then the same thing happened here. What it looked like a lot of kids did on these how far ones for 6B and 7B is you took the velocity times the time. And so the problem with that is that's how you would do it if it had gone that velocity the whole time, or that speed the whole time. But because it's accelerating, it's only going that speed at the very end of that time period. So you can't use that speed to calculate it. Let's see here. Then we got to number 9. And so number 9 we've talked about in class. So I put equations here to get you to the answer. I actually prefer you to think of, if you can think of 9 more conceptually, where we did in class, where my acceleration is 2.5 meters per second, then after 1 second, I'm going 2.5. After 2 seconds, I'm going 5. After 3 seconds, I'm going 7.5 meters per second. And after 4 seconds, I'm going 10. And then after 5 seconds, I'm going 12.5. That's really the mental part that I'd want you to be able to think on your feet a little bit there. The equations are there, and they're nice, and they're helpful a lot of times, but we also want you, to try to visualize this in your head, which, doing this virtually is probably one of the harder parts. So we've answered those. Now here, average speed was tough, right, for a lot of kids. And here's how I'd want you to think of this one. It's going to roll down this inclined plane. So it started from rest and ended at 7.5. So the average of 0 and 7.5, what you would do is you would add those things together, 0 plus 7.5, and, oops, I did it equal, 0 plus 7.5, and I got 2 numbers there, so I divide it by 2, and that is going to give me 3.75 meters per second. So, if hey, something went from 10 to 40 meters per second, what was the average? Well, it's the average of 10 plus 40 divided by 2, or it's 10 plus 40 divided by 2. So anytime you have 2 numbers, you just add them together, divide by 2, and that gives you your average. How far? So now we figured out, we knew acceleration given to us in the problem here. We knew in those 3 seconds. So, so then we're just plugging those numbers in, and we get 11.25 meters when you plug 2.5 in here for acceleration and 3 in there for time. And then this question, as we talked about in class, it's just remembering what you're doing. What's the ball's acceleration? Well, it's a constant acceleration of 2.5 meters per second. So, excuse me. So that's how we solve those. And as you look over your work and compare it with this, then hopefully that makes sense. And if not, then we want to schedule some time to meet.